Then this is that second type, updraft gasifier. This is also called as counterflow gasifier, which is very simple and first type of the gasifier. Air is flown below the combustion chamber. You can see in the picture, the air is flown below the combustion chamber. Gas is drawn off from the top. Okay, gas is clean but contains the tar and some water vapor, and which is not suitable for high volatile fuel. Okay, then you can look at the picture. Again, here the zones are same, like there is oxidation zone, reduction zone, and the pyrolysis zone, and then drying zone, wood chips, and the biomass hopper is again at the top. Okay, air, instead of the previous case, the air was flown from the top surface. Now here the air is primarily from the bottom surface only. Okay, so this air is flown from the bottom surface. The ash is collected at the bottom. The air is actually being used for the oxidation. Then again the heat transfer takes place from this zone to the upward, and definitely there is a formation of gas, and that gas can be tapped from the upper surface. So this is that gas out, but this system is not suitable for the high volatile fuels. Now here is that third type of the fixed gasifier, fixed draft gasifier, that we call as cross draft gasifier. You can see in the picture, the air enters through the water cooled nozzle mounted on one side of the firebox. This entire gasifier is operating at very high temperature. It confines the combustion near the nozzle zone. The exit temperature of the gases is really very high. That's why it is very difficult to actually use that gas for some actual application. That's why this gasifier is not commonly used in the actual practice. Okay, so this is that cross draft gasifier. So in all, the downdraft gasifier is mostly used in the industry. Then second is that updraft gasifier, and we are not actually using this next type of the gasifier that we called as the cross draft gasifier. Then this is again one more type of the gasifier that we called as fluidized bed type. A fluidized bed gasifier takes the advantage of excellent mixing characteristic and high reaction rate of the gas solid mixture. A simple fluidized bed gasifier is a chamber with a bed of inert particles such as sand or the limestone supported by distributor plate. You can see in this case there is the distributor plate, and this is the fluidized bed. This fluidized bed is simply the fine limestone or the sand particles. Okay, a pressurized air is passed through the distributor plate. The velocity of the air is progressively increased till the upward drag of the air on the bed particles supports the entire weight of the bed. The bed is then said to be incipitantly fluidized. Okay, and it exhibits fluid-like properties above this velocity called as minimum fluidization velocity. This moving mass of the solid is called as fluidized bed. The turbulence of the bed increases with velocity above minimum fluidization velocity. The fluidized bed is initially heated externally close to the operating temperature. The bed material, usually sand, absorbs the store, the heat, while the turbulence and the mixing of the bed keeps the temperature very uniform throughout the bed. When the biomass fuel is introduced into the fluidized bed, the high heat and the mass transfer characteristics permit the rapid energy conversion at a particularly isothermal condition. The high surface area available in fluidized bed and constantly moving mass results in good conversion efficiency and the lower operating temperature compared to the fixed beds. The fluidized bed design procedures, and it actually produces a gas with the low tar content but high value of the particulate. The high exit temperature complicates the energy efficient recovery of this system, similar to your previous case. That is I think the case of the cross draft type of the system. Again, this type of the system is efficient system, but this system is not being used in the common practice. Okay, so these were those different types of the gasifier. So this ends your gasification process. Now in the next slide we are going to see the next process that we called as a conversion of the biomass into the gaseous fuel with the help of the fermentation process, that is anaerobic digestion process, that we called as biogas production. Here I have one small video on
chemical conversion process uses heat to break down biomass into intermediates, such as gas or bio-oil, that can be upgraded into fuel and other products. One type of thermochemical conversion process is gasification. a method that uses heat to turn biomass into a hydrogen and carbon monoxide-rich gas called synthesis gas, or syngas. This in turn is converted into liquid transportation fuels or other products. Gasification occurs at relatively high temperatures. Here's one example of a gasification conversion process. Wood material such as forest residue is a common feedstock for the gasification process. For best results, feedstock wood chips are no more than 2 inches in size and have 20% to 30% moisture content by weight depending on the gasifier. In the gasifier, the biomass is broken down into vapors in a carefully controlled environment that typically contains oxygen and/or steam. The syngas produced is made up of carbon monoxide and hydrogen. Char, a solid byproduct of gasification, is typically removed using a cyclone. Cyclonic separation allows removal of particulates from a gas stream without a filter by using rotational effects in combination with gravity to collect the particles. Tars and methane are also produced. Their quantity and composition depend on the gasification environment. Tars are high molecular weight organic compounds. If they are not removed, these tars will contaminate downstream equipment and inhibit fuel synthesis. One way to remove methane and tars is by using special catalysts to convert the compounds into additional syngas, thus eliminating the methane and tar problem while also improving the efficiency of the process. Additional cleaning and conditioning steps may be required to remove other contaminants such as ammonia, sulfur, and carbon dioxide. The syngas is then conditioned to produce the desired ratio of carbon monoxide and hydrogen to achieve optimal chemical reactions in subsequent steps. The pressurized hot syngas is then passed over a catalyst to form a liquid. The catalyst is contained in a reactor, and the syngas is passed through the reactor, where the carbon monoxide and hydrogen molecules combine to form larger molecules. These molecules are subsequently cooled, condensed, and refined into clean, renewable transportation fuels and other products. The Department of Energy has supported development of innovative technologies that result in higher yields and superior quality of biomass syngas. These efforts have also resulted in a much more thorough understanding of the gasification process. Enabled by these advancements, industry is deploying gasification technologies that will bring clean, renewable transportation fuels and other biomass-based products to the marketplace.